back, guys. So we will continue our discussion on thermodynamics. So in this video I am going to discuss or solve some of the entrance exam questions based upon what we have learned till now. So the questions are mainly from JEE Advanced and KVPY. The reason why I selected questions from these exams are because you really need a better conceptual understanding of the subject in order to solve questions which comes in JEE Advanced and KVPY. So when we are solving this, it will help us to improve our conceptual understanding of the subject. So we will do that in this session. So this is a JEE 2019, JEE Advanced 2019 question paper, and this is a multiple answer type question. That is, more than one option can be correct. So let us read the question. One mole of a monoatomic ideal gas goes through a thermodynamic cycle as shown in the volume versus temperature diagram. The correct statement is R. R is the gas constant. So before solving the problem, the most common question which comes from thermodynamics is based upon the diagram. So when means there can be questions, problem questions also, but most of the question usually in the entrance exams are diagram based. So whenever you have a diagram based question, the first thing which you should do is that you should try to understand what each steps in the diagram represent. What are the different process each steps represent. So that's the first thing which you should do whenever you get a diagram based question from a thermodynamics chapter. So the path or the process 4 to 1 and 2 to 3 are isochoric. That is something which is very well evident from the graph. You can see that V is constant in process 4 to 1 and 2 to 3. So 4 to 1 and 2 to 3 are isochoric processes. Now 1 to 2 and 3 to 4. Now when the system moves from the state 1 to state 2, you see that the temperature is initial temperature is T0 and the final temperature becomes 2 times T0. At the same time, the initial volume is V0 and the final volume becomes 2 times V0. So what you see here is that the temperature and volume is proportional to each other. So when the volume and temperature are proportional to each other, in the case of ideal gas, you know that the pressure is constant. So we can say that in the process 1 to 2, it undergoes an isobaric process. Now the same is the case with 3 to 4. So here 3 is the initial state and 4 is the final state. So in 3 you can see that the temperature is T0 and the volume is 2 V0, but when it comes to 4, the state 4, its volume reduces by half, that is V0. At the same time, the temperature also reduces to half, that is T0 by 2. So again, in this case, you see that volume is directly proportional to T. So we can say that this process is also isobaric. So process 1 to 2 and 3 to 4 are isobaric. Now here you can see that option B, the above thermodynamic cycle exhibits only isochoric and adiabatic process. So as you can see that the main two processes which take place in this diagram is isochoric and isobaric. There is no adiabatic process. So option B is wrong. Now first option says that work done in the thermodynamic cycle is equal to 1 by 2 RT0. So the work done in this complete cycle is 1 by 2 RT0. So that means we have to calculate the complete work done in this process. So as you know, in the process 4 to 1 and 2 to 3 are isochoric processes, and you know that work done during an isochoric process is 0. So there is no work done during these processes. So we have to only calculate the work done during process 1 to 2 and 3 to 4. So that's then isobaric process. So work done during an isobaric process is equal to nR T2 minus T1. This is we have already derived this equation in our previous video. So only thing we have to do is that we have to substitute the initial and final temperature. So in the process 1 to 2, the initial temperature is T0. So here it's T0 and the final temperature is 2 times T0, so 2 T0. So this will becomes T0 into R. Work done during process 1 to 2 is T0 into R. Now work done during 3 to 4. So again R into the final initial temperature is T naught, so again T naught, and the final temperature is T naught by 2, T naught by 2. So you see that the work done during this process is negative, and it's equal to minus R T naught by 2. Now this is something which you can understand from the graph itself. You can see here in the process 1 to 2, you see that V naught changes to 2 V naught. That is, the volume of the system increases. That means the system is doing the work. So we get a positive work done here. And in the process 3 to 4, you see that the initial volume was 2 V naught and the final volume is V naught. So the volume decreases. So we understand that work is done on the system, and we get here the work done to be negative. So this is something which is in accordance to what we have learned. And if you add these two work done, that is RT naught minus RT naught by 2, you get RT naught by 2, and that's what the statement 1 says. So work done is equal to RT naught into half. So the first statement is correct. Now as this is a multiple answer type question, so there can be more than one answer, so you have to look to option C and D. So in option C and D, they are comparing the ratio of heat released or absorbed during different processes. So what is the equation which we have in hand in order to calculate the heat absorbed or released? So one of the equation is dq is equal to ncv dt plus pdv, and another equation is dq is equal to ncp dt minus vdp. We have already derived these two equations. Now the first one compares the heat energy released or absorbed during process 1 2 and 2 3. Now what is process 1 2? Process 1 2 is isobaric process. So in isobaric process, as you know, the pressure remains constant. So in this equation, during isobaric process, this dP becomes 0. So you get dQ is equal to ncp dt. Now in the process 2 to 3, its volume is constant, so we have to use this equation. And during constant volume, you know that dV is equal to 0, so you get dQ is equal to ncv dt. So in the end, what is q1 by 2 by q2 3 is nothing but cp by cv by cv. And for monoatomic gas, cp is 5 by 2 and cv is 3 by 2, which you will learn in the chapter kinetic theory of gases. So if you substitute that here, you will get that q1 by 2 by q2 by 3 is nothing but 5 by 3. If you don't, as it is monoatomic gas, that's why we get this equation, this to be equal to 5 by 3. So in option D, they are comparing the heat energy transfer during process 1 to 2 and 3 to 4. So 1 to 2 and 3 to 4. So as this is an isobaric process, so you have to use this equation, and in this process pressure is constant, so this term goes to 0. So when you take the ratios, the only thing N and Cp are constant, so the only thing which changes is this change in temperature. So in the process 1 to 2, the change in temperature is T naught, and in the process 3 to 4, the change in temperature is T naught by 2. So what you get is that the ratio between Q1 by 2 and Q3 by 4 is nothing but 2 is to 1, but here it's given 1 by 2, so option D is wrong. So in this question, the correct options are option A and option C. So this is a JEE Advanced 2018 question. So let us read the question. And this question is a mass T type question. 1 mole of a monatomic ideal gas undergoes 4 thermodynamic processes as shown schematically in the PV diagram below. Among these 4 processes, one is isobaric, one is isochoric, one is isothermal, and one is adiabatic. Match the processes mentioned in list 1 with the corresponding statements in list 2. So the first thing which we have to do in this question is we have to identify what each number represents, number represents which process. So we will begin with 2, we will come back to 1 and 4 later. So the process 2 is isobaric, that's quite evident from the graph. You can see that pressure is constant, so it's an isobaric process. Now in process 3, you can see that the volume is constant, so it's an isochoric process. Now we have left with only isothermal and adiabatic process. So which one represents isothermal or adiabatic process. If you have listened to my previous video, I have compared the slope of adiabatic process and isothermal process in a PV diagram. So what we learned there is that the isothermal process has a greater slope than the isothermal process. So the adiabatic, as the adiabatic has more slope than the isothermal process, the process 1 represents the adiabatic and process 4 represents the isothermal process. So process 1 is adiabatic and process 4 is isothermal. So I am repeating once again that as 1 has more slope here, and we have already discussed that adiabatic has more slope than isothermal, therefore process 1 represents the adiabatic process and process 4 represents the isothermal process. So now we have to match these things to list 2 based upon the information which we have here. So in process 1, so we know that process 1 is adiabatic. So work done by the gas is 0. So obviously work done during an adiabatic process may not be 0. So this is wrong. This cannot be matched here. The temperature of the gas remains unchanged. No, the temperature can change. And third, no heat is exchanged between the gas and the surroundings. So option, we have to match P with 3 because as you know in adiabatic process there is no heat exchange between the system and the surroundings. So P is matched with 3. So it's option C or D. Now next process 2. Process 2 is isobaric process. So work done by the gas is 0. No, in the as you know in the PV graph, the work done is nothing but the area under the graph, and you can see that there is some area under this graph. So obviously work done is not 0. Next, temperature of the gas remains unchanged. So in isobaric process only pressure remains constant. No heat is exchanged between the gas and the surrounding. That's also wrong because heat exchange can take place. Now work done by the gas is 6 P naught V naught. So this is something which is correct, as you know that work done in isobaric process is W is equal to P into V2 minus V naught. So here P is 3 P naught and the change in volume, the end volume is 3 V naught and the initial volume is V naught. So the difference is 2 V naught. So 3 V naught into 2 V naught will give you 6 V naught V naught. So we have to match Q with 4. So again it's option C or D. Now next process 3. Process 3 is, as you know, it's isochoric process. So in isochoric process you know that work done is 0. So R should be matched with 1. So it's actually option C. Anyway we will look for the S also. In process 4, 4 is nothing but isothermal process, the temperature remains constant, so S should be matched with 2. So the option is C. So this is again a question from JEE Advanced 2018, and this is a multiple answer type question. So that means more than one answer, more than one option can be correct. 1 mole of a monatomic ideal gas undergoes a cyclic process as shown in the figure, where V is the volume and T is the temperature. Which of the following statement below is true? So first of all, we should try to understand what does each step in this process represent. So as you know, step 2 and 4, you can see that the temperature is constant. So we can understand that it's an isothermal process. So 2 and 4 represents an isothermal process. But when you see 1 and 3, this is something which we haven't learned, and we are quite not sure what the process 1 and 3 represent. So we will leave it here. Now, process 1 is an isochoric process. So it's not an isochoric process because if it's an isochoric process, the volume should be constant and it should be a straight line. But this is not a straight line, so this is not an isochoric process. So option A is wrong. Now, process 1 and 3 are not isobaric. 1 and 3, it's quite evident that 1 and 3 are not isobaric. Why is it that so? Because if it was an isobaric process, as you know that volume and temperature are temperature are directly proportional if the pressure is constant and it's a straight line which passes through the origin. But the processes 1 and 3 does not pass through the origin, and you can see that T and V are not directly proportional. So the 1 and 3 are not isobaric processes, and that's something which is true. So option D is correct. Now here they say that in process 2 gas absorbs heat. So 2 is an isothermal process. So in isothermal process, as you know, in the case of an ideal gas, there is no change in internal energy. So what happens is that delta Q becomes work done. So in this case, the process 2, you can see that the system moves from left side to right side. So and the volume of the system increases. So what happens when volume of the system increases? When volume of the system increases, the system actually does work. So when system actually does work, it's actually positive, and delta Q is positive. So when delta Q is positive, that means that heat is absorbed by the system. So in process 2, gas absorbs heat. So that is a correct statement. Now in process 4, gas releases heat. Now in process 4, as you see that the volume decreases, the initial volume is greater than the final volume. So as the volume is decreasing, we can understand that someone is doing work on the system. So when work is done on the system, it's negative. As this is again an isothermal process, delta Q is equal to delta W, and since W is negative, delta Q is also negative. So when delta Q is negative, that means that heat is released by the system. So in process 4, gas releases heat. So option C is also correct. So in this question, option B, C and D are correct, and option A is wrong. Now this is a KVPY question. For an ideal gas, the internal energy is given by U is equal to 5 PV by 2 plus C, where C is a constant. The equation of the adiabatic in the PV plane will be. So it's nothing but if the internal energy is given by U is equal to 5 PV by 2 plus C, then you have to find the equation for the adiabatic process. So the only thing we know about the adiabatic process is that there is no heat exchange and dq is equal to 0. So the only equation which we have about dq is dq is equal to du plus pdv. Now we have u here and we need du here. So what we have to do is that we have to convert this u given in the question to its differential form. So if you when we are converting this into its differential form, we have to apply the product rule, and then you will get that du is equal to 5p dv by 2 plus 5v dv by 2. So we have applied the product rule, and this is what we get the differential form of the internal energy. And now we substitute this du in this equation, first equation. So we get in the first equation we have already PdV. So what happens is that adds up with the 5 by 2 PdV which we have in du, and we get dq is equal to 7p dv by 2 plus 5v dp by 2. Now as we have to find the equation for the adiabatic process, dq is 0. Now if dq is 0 and if you take one of this to the left hand side, you get 7p dv by 2 is equal to minus 5v dp by 2. Now you take p to the RHS and v to the LHS, and you integrate it. So this is what you get when you exchange p and v to the other side. So 7 dv by v is equal to minus 5 dp by p. Now you integrate this. So when you integrate this part, you get ln v raised to 7 equal to minus ln p raised to 5 plus a constant, the constant of integration, and that constant I have equated to ln into k, where k is another constant. Now if you take minus ln p to the left hand side, you get ln v raised to 7 plus ln p raised to 5 is equal to ln k. Now this is of the form ln a plus ln b, and as you know that ln ab is equal to ln a plus ln b. So what we get is nothing but ln p raised to 5 into v raised to 7 equal to ln k, and if you remove the ln, you get p raised to 5 into v raised to 7 is equal to a constant. So option A. So this is the thing which we got is nothing but option A. So option A is Correct. Now, if you see that this process is something similar to the process by which we derived the equation for the adiabatic process, that is P into V raised to gamma is equal to constant. Now, this is again a question from JEE Advanced, and it's a quite interesting question, and this is an integer type question. That is, the answer will be an integer to this question. A thermodynamic system is taken from an initial state I with internal energy Ui equal to 100 joule to the final state F along two different paths, that is path IAF and IBF. This is IAF and IBF as schematically shown in the figure. The work done by the system along the path AF, IB and BF are WAF is equal to 200 joule, WIB equal to 50 joule, WBF is equal to 100 joule respectively. The heat supplied to the system along the path IAF, IB, BF are QIAF, QIB and QBF respectively. If the internal energy of the system in the initial state B if the internal energy of the system in the state B, that is this state, is UB equal to 200 joule and QIAF is equal to 500 joules, then you have to find out the ratio of QBF by QIB. So that is, you have to find out the ratio of the heat transfer when the system moves from B to F and I to B. So you know that dQ is equal to du plus dW and QIB is equal to UIB plus WIB. Now it is given that the internal energy at I is 100 joule and internal energy at B is 200 joule. So the change in internal energy in this process IB is nothing but 200 minus 100, so that's 100, and they have already given the work done WIB equal to 50 joule, that is the work done when the system moves from I to B. So we get QIB is equal to 100 joule plus 50 joule, that is 150 joule. Now we have to find the heat transfer in the process B to F. So QBF is equal to UBF plus WBF, and they have given WBF is equal to 100 joule. But if you read the question once again, you will see that they haven't given UBF. We require the internal energy change when the system moves from B to F in order to calculate QBF. But it's not given in the question. So here we have to use a very important thing which we have learned in this chapter, that is, internal energy of the system is a state function. It depends only, the change in internal energy depends only on the initial and final state. So we know the internal energy change when it moves from I to B, and we have to find the internal energy change from B to F. So what we will do is that we will calculate the internal energy change when the system moves from IA through the path IAF, and this change in internal energy will be equal to the change in internal energy which takes place when it moves from the path IBF. So that is UIF, that is the internal energy change which takes place when the system moves along the path IAF, is equal to the internal energy change when it moves along the path IBF. So I have splitted that into UBF plus UIB. So we have to calculate UIB and we have to calculate UBF, and we have UIB already, and if we calculate UIF you will get the UBF. So we will calculate the UIF. Now QIF is equal to UIF plus WIA plus WF, that is the heat transfer which takes place when the system moves through the path IAF is equal to change in internal energy when it moves along this path plus the work done when it moves from I to A plus work done when it moves from A to F. Now the work done when it moves from I to A, you can see that it's an isobaric process, the volume is constant, so the work done is 0, so WIA is 0. So WAF is already given, that is 200 joule, and from this equation, and you have QIAF is equal to 500 joule. So from this equation you get UIF is equal to 300 joule, that is 500 minus 200, that is 300 joule. Now If you substitute this 300 joule here and you know that UIB is equal to 100 joule, you get UBF is equal to 200 joule. So we have got the internal energy change which takes place when it moves from B to F, using the fact that the internal energy is a state function and the change in internal energy depends only on the initial and final position. So now QBF becomes UBF, that is 200 joule, plus WBF, that is already given in the question, that is 100. So QBF is equal to 200 joule plus 100 joule, that is 300 joule, and the ratio between QBF and QIB, that is 300 joule divided by 150 joule, that is nothing but 2. So 2 is an integer and the answer which we got is correct. So the main important point which this question uses is the internal energy is a state function. So this is a question from KBPY 2016 paper. A gas at initial temperature T undergoes sudden expansion from volume V to 2V, then which of the following statements are correct? So first of all, let us look option D, that is the entropy in the process does not change. So as the system expands from V to 2V, the gas inside it has more disorderedness, means as the volume increases, the gas has more volume for it to occupy and move, so it moves more randomly, therefore the entropy of the system actually increases. But the statement D says that the entropy of the process does not change, so this option is wrong. Now the process is isothermal. There is no requirement that the temperature should remain constant during this process. So that is when the volume changes from V to 2V, the temperature can change from T to some other value. It need not be at constant temperature. So the process is isothermal. So this statement is also wrong. The work done in this process is nRT ln2. Now, if you remember the work done during an isothermal process, that is nothing but nRT into ln V2 by V1. So, if here V2 is 2V and V is V, so 2V by V is nothing but 2. So, nRT ln2. We get the work done as nRT ln2. So this is the work done during an isothermal process, and we have already stated that the process may not be isothermal. So option C is also wrong. So the correct answer actually is the process is adiabatic. So why is this process is adiabatic? So as the expansion takes place suddenly, that is it suddenly changes from V to 2V in a very short period of time. As a result, the system has no time to exchange the heat between the surroundings. So as the expansion takes place very fast, there is no heat exchange between the system and the surrounding because it takes place spontaneously. As a result, it's an adiabatic process. So option A is correct. So this is a question from KVPY 2010 question paper. Van der Waals gas obeys the equation of state P plus n square A by V square into V minus NP is equal to nRT. Its internal energy is given by U is equal to Ct minus n square A by V. The equation of the quasi-static adiabat for the gas is given by. So this question is something similar to the question which we have already done, where we have to find the equation for the adiabatic. This question is also similar, but the only difference is that here we have a Van der Waals equation of state, there we had a ideal gas equation of the ideal gas equation, where we had an ideal gas, and here we have a gas which obeys the Van der Waals equation. Now, as usual, dq is equal to du plus pdv, and here we have given the equation for u, that is u is equal to ct minus n square a by v. So we have to convert into the differential form. So it becomes du is equal to c dt plus n square a dv by v square. Now, the only change which comes here is that in the options you see that the everything has been done in terms of written in terms of T and V. So what we have to do is that we have to eliminate this P in this equation. So for that we will use the van der Waals equation. So we will take all the things except P from the left hand side to right hand side. So then we get the expression for P, that is P is equal to nRT by V minus NB minus N square A by V square A. V square. So what we will do is that we will substitute this here and we will substitute this du which we have got here. So the equation changes, dq is equal to c dt plus remaining thing. I am not reading it out. So we have to find the equation for the adiabatic process. So for the adiabatic process, dq is 0, and you see that there is plus n square a dv by v square and minus n square a v square by dv. So these two things cancel out, and we have taken dq is equal to 0. So the equation becomes c dt equal to minus nRT by v minus nb into dv. Now as usual we have to just integrate this. For that, first of all we need to bring this t to the left hand side and this and nothing else. So we get c dt by nRT is equal to minus dv by v minus nb, and if you integrate this you get ln into t raised to c by nr is equal to minus ln into v minus nb plus lnk, where here we have the constant of integration, and I have taken the constant of integration to be lnk, where k is another constant. So if you take this to the left hand side you get ln t raised to c by nr plus ln v minus nb is equal to ln k, and if you remove the ln you get the equation t raised to c by nr into v minus nb equal to constant, so which is option C. So we have actually done two questions based upon to find out the adiabatic process. So if any such question comes, I hope that you will be in a position to do, and I will stop this session here. I hope that by solving these questions it must have improved your concepts about thermodynamics and might have helped you to understand how to approach a question in entrance exams. So I will stop here.